Okay, I'm going to be straight with you guys. This is one of the hardest things you're going to do in Algebra 1. At least it is for me, or it was when I learned it. But we are going to be factoring trinomials. Trinomials, as you remember, are expressions that have three terms, just like tricycle has three wheels. And another way of thinking about factoring is you are unfoiling. And here's what I mean by that. If I gave you two binomials and I said I wanted you to FOIL them, you'd say, okay, well that's first, outside, inside, last, combine like terms, and now I have FOILed. I've made two different binomials into a trinomial. The idea behind factoring is that we're going to go the other way. We're going to be given the trinomial and we need to factor it back into binomials. And the best way I can explain it is it's not simple, and it's going to take some concentration. I've got 9 examples to go over, but you're going to need to practice this more than just during this video to get it. When we see something in the form ax squared plus bx plus c, this is known as standard form of a quadratic equation. And the way we are going to go about factoring is we are going to use what is called a sum and product chart. To find the sum is going to be based on b, okay, that's the coefficient of the middle term, and the product is going to be a times c. And so I know that doesn't sound simple, so let me just try and walk you through one to see if we can get an idea. So this is in standard form, meaning the quadratic form, the squared term is first, then the linear term, then the constant. Well, the sum here, okay, is going to be b. That's going to be 7. And the product is going to be a times c, or 2 times 6, which is 12. So what we're looking for, okay, is we're looking for the factors of 12 that add up to 7. And what I mean by that is 12 can be 1 times 12, 2 times 6, or 3 times 4. Which of these three choices add up to 7? Well, 3 and 4 add up to 7. So when we go to factor, we're basically going to take our trinomial and then we're going to make two separate binomials. The lead term comes down first and then the last term goes in here. What we're trying to do is figure out how are we going to divide up this 7x. Are we going to put 2 here and 5 here, or 1 and 6? What we found though was by using the sum and product joints, we're going to separate it into 3x and 4x. And it makes no difference if you put the 3x or the 4x in which spot. So if you put 4x here and 3x here, it still works. Now going back to what we did with factoring with grouping, look at the first two terms. What is the GCF between these two terms? Well, it looks like it's x, leaving us 2x plus 3. And what is the GCF between 4x and 6? I believe it's 2, leaving us 2x plus 3. 2x plus 3 and 2x plus 3 means we can, just like we did with grouping, rewrite this as x plus 2 times 2x plus 3, and you have just factored a trinomial. If you want to make sure you're right, go back and FOIL it and make sure that you get that answer. But that is how you go about factoring. More examples. 2x squared plus 11x plus 5. So you start by making your binomials. The 2x squared comes down and the 5 comes down. The only question is, how am I going to distribute the 11? Am I going to put 10 here and 1 here? Am I going to put 6 and 5, 8 and 3? Well, that's where our sum and product chart comes in. We know the sum has to be 11 and the product has to be 2 times 5, which is 10. So the different ways you can factor 10 are only 1 times 10 or 2 times 5. Which ones add up to 11? 1 and 10. So 1x and 10x. Here, greatest common factor is x, leaving 2x plus 1. Here, the greatest factor is 5, also leaving, 2x plus 1. Go ahead with your grouping. X plus 5, 2x plus 1. One nice thing is it never changes. always the first term here, the last term here. The only question is how are we going to divide up 27? Well, if we're looking for a sum of 27, and in this case a product of 5 times 10, which is 50, well, 1 times 50, 2 times 25, 5 times 10, but I can stop right there because I know that 2 and 25 add up to 27. So put them wherever you like. We can put the 25 here and the 2 here if we like. GCF here is going to be 5x, leaving x plus 5. GCF here is going to be 2, leaving x plus 5. 5x plus 2 times x plus 5. Now, every one of those examples, all the terms had were positive. So let me show you an example where the middle term, the linear term, is negative. Doesn't change things a whole lot. Okay? Like any other problem, lead coefficient here, last term constant here. Question is how are we going to divide up negative 13? Well, we're looking for the factors of 2 times 21, so we're looking for the factors of 42. 2 times 21, 3 times 14, 6 times 7. Wait, 6 times 7, 6 and 7 add up to 13, but they have to add up to negative 13, so what if we made them negative 6 and negative 7? Because a negative times a negative is a positive, they still would multiply to make positive 42, but they would add to make negative 13. So really, when you're looking for the factors of 42, if you're looking for a sum of negative 13, all the factors have to be negative. So let's do negative 6x and negative 7x, which gives us 2x times x minus 3. And if we take out a negative 7, we'll be left with x minus 3. The reason I took a negative 7 is because if I took a positive 7, I'd be left with negative x plus 3. And when I needed positive x minus 3, so I just pulled out a negative 7, and then put your terms together. You're factoring, baby, and you can remember, like I said, you can always FOIL it and check and make sure you get that same trinomial. It gets a slightly bit trickier when you start seeing the third term as negative. So now we're looking for a sum of negative 4 and a product of negative 21. So we're going to have to list the factors of 21, 1 and 21, and I think the only other choice is 3 and 7. So to make a product of a negative number, that means one of these numbers has to be negative and add up to negative 4. Well, if I make negative 3, if I make this negative 3 and positive 7, so negative 3 and positive 7 would be positive 4. But if I did negative 7 and positive 3, those do add up to negative 4. So those are my guys. So 3x squared at the beginning, negative 7 at the end, and then I'm going to have to put negative 7x here and positive 3x here. I've got x as the GCF for the first one, and then notice I don't have a GCF here. They don't have anything in common. So what we can do in that case is we can just say, well, 1 is always a GCF when you can't find anything better, so we wind up with x plus 1 times 3x minus 7. Let's practice a couple more like that. 5x squared minus 9x minus 2. 5x squared, negative 2. The only question is how we distribute the negative 9. So that's our sum, and our product has to be negative 10. I already see it. 2 and 5 aren't going to add up to 9, but I think negative 10 and positive 1 will sure add up to negative 9. So let's go negative 10x and then plus 1x. So if we take out a 5x here, we'll be left with x minus 2. And same case like the previous one, if there's no GCF here, we can always factor out a 1, and we wind up with 5x plus 1 times x minus 2. One more. Last one. 6x squared plus 11x minus 10. So we're looking for a sum of 11 and a product of negative 60. So 6x squared, negative 10, and then the only question is how do we distribute the 11? Oh, let's see, 1 times 60, 2 times 30, 3 times 15, 4 times, no, not 3 times 15, 3 times 20. Silly. 4 times 15. I think there's a winner. I think if we did positive 15 and negative 4, they would multiply to make negative 60, but add up to make 11. So we'll do negative 4x here, positive 15x here, and let's see how this does. 2x will leave me 3x minus 2, and if I take out a 5 here, that'll leave me 3x minus 2, so my ultimate answer, 2x plus 5 times 3x minus 2. That's how you do it. I know, don't be discouraged if you have difficulty with this. Like I said, I think this is one of the hardest things to learn in Algebra 1. It takes practice, and there's plenty of examples you can get off the internet to practice it and make sure you're right, but always remember that you can go back and FOIL it to check and see if you had it right from the get-go. All right.